Hello again. Okay, these are the questions and answers on rates of reactions. Let's see if you were able to get the correct answer. So the first question says the apparatus shown can be used to measure the rate of some chemical reactions. For which two reactions would this apparatus be suitable? Now remember, when do we use a gas syringe? To measure the volume. The volume of what? Of a gas. So we can use it only if the reaction gives out a gas. So you look for the reactions in which there is some sort of gas after the arrow. So the only ones that give out a gas are reaction 2 that gives oxygen and reaction 4 that gives carbon dioxide. So it is 2 and 4. Okay, only reactions that give out gases. The rate of reaction depends on temperature, concentration, particle size, and catalysts. Which statement is not correct? Again, I'm going to remind you, sometimes he says which statement is correct or which statement is not correct. So let's look at the first statement. A says catalyst can be used to increase the rate of the reaction. Is that right or wrong? Of course it's right. Higher concentration decreases the rate? No. Higher concentration increases the rate. So this is the one that is not correct. Okay, so this is not correct. Now let's look at the other one. C says higher temperature increases the rate. Yes. Larger particle size decreases the rate. Yes, because we said larger particle size is less surface area, and when I cut it into smaller particle sizes, then I'm increasing the surface area, so the rate increases. Okay, which graph represents what happens when sodium carbonate reacts with excess acid? Now remember that carbonate with acid will give out a gas, carbon dioxide gas, and we said any reaction that gives out a gas would the mass of the reaction would decrease. So my answer is B. Remember that if no gas is given off or nothing escapes from the reaction, then I will have the graph D, in which the mass does not change. Okay, the graph shows the results of two experiments, R and S. Which changing conditions will cause the difference between R and S? Now, the first thing I'm going to ask myself, which one is faster, R or S? Of course, R has the steeper slope, so R is faster. So you want to choose the statement that makes R faster. Okay, so he says number A catalyst is added in S. No, if a catalyst is added in S, then S would be the faster one, and that's not right. The acid is more concentrated in R than in S. Yes, that means that's my answer. The acid is more concentrated in R than in S, so that would make R faster. Now, just to check, you have to go through the others and make sure that they are not the correct answer. So C says the magnesium is less finely powdered in R than in S. Less finely powdered would make it slower, not faster. So C is wrong. The temperature in R is lower than S. No, if it's lower, it wouldn't be faster. So B is the right one. Okay, the diagram shows an experiment to compare the speed of reaction when limestone chips are added to acid. Which reaction is faster? So let's see, what are the conditions? First of all, A and B are concentrated, C and D are dilute. Which one would be faster, concentrated or dilute? Concentrated. So my answer is either A or B. And then the pieces of limestone in A are large pieces, or what we call lumps. The ones in B are smaller pieces. So which one would be faster? The smaller pieces. So that is the faster reaction. Do we understand that? Why does the rate of a gaseous reaction increase when the pressure is increased at a constant temperature? So he's saying he's increasing the pressure. Why does the rate increase? More particles have energy that exceeds activation energy? No, pressure does not add energy to the particles. The particles have more space in which to move? No. When we increase the pressure, the particles are nearer to each other, so actually they have less space. The particles move faster? No, the particles move faster only if you increase temperature, not pressure. There are more frequent collisions? Yes, there are more frequent collisions because the particles are nearer to each other, so there is more collisions. Okay, powdered marble reacts with hydrochloric acid using the apparatus shown. The gas syringe fills in 36 seconds. So it takes 36 seconds for the syringe to fill up. Now the experiment is repeated. He was using powdered, remember? Powdered marble. Now he's going to use marble chips. You have to know the difference between these words. Powdered marble, that means very, very, very tiny pieces. Marble chips are bigger pieces. So now he's going to use larger pieces. So we're going to ask ourselves, larger pieces makes the reaction faster or slower? Actually, it would make the reaction slower. Slower means takes more time or less time? Slower reaction takes more time. So my answer must be the one that is more than 36 seconds. Do we understand that? Okay. Ethanoic acid reacts slowly with calcium carbonate. Which statement explains why an increase in temperature increases the rate? So we're increasing temperature, this increases the rate. Why? Activation energy is decreased? No. When we increase the temperature, the activation energy is actually the same. The only thing that affects the activation energy is the catalyst. So the only thing that will make the activation energy decreased is if I added catalyst, not if I increase temperature or if I increase pressure or any of the other factors. So one is wrong. So there is an increase in collision rate. Yes. When I increase temperature, we said the particles will have more energy, and that actually means that number 3 is correct, and there is an increase in collision rate. So 2 and 3 are correct. Now, there will be fewer successful collisions? No, there will be more successful collisions. So my answer is C. Reaction speed increases. Again, I'm going to just remind you the word speed is exactly the same as rate for our purposes. Reaction speed increases as the temperature increases. Explain why the reaction speed increases with temperature. Again, why is it that when I increase temperature, the rate of the reaction is more, or the reaction is faster? This is because what? The particles gain more kinetic energy, move faster, collide faster, in that order. Please don't change the order. You can't say the particles collide faster then have more kinetic energy. No. When you increase the temperature, that causes the particles to have more kinetic energy. Now, once they have more kinetic energy, they start to move faster. Once they move faster, that means collide faster. And more of the molecules, now the third point here, is that when you increase the temperature, remember, more of the molecules have energy higher than activation energy. So we said if they have energy higher than activation energy, then the collisions will lead to reactions. Explain why the reaction speed increases with increase in pressure. Now, when I increase pressure, why does the speed increase? Because increase in pressure, and this is specific for gases, increases the rate of reaction because particles are closer to each other, so more collisions. Okay, an organic compound decomposes to give off nitrogen gas. The speed of this reaction can be determined by measuring the volume of the gas at regular intervals. Typical results are shown in the graph, and he shows you the graph. Now, the reaction is catalyzed by copper. Sketch the graph for the catalyzed reaction. So this graph that he drew is for the reaction without catalyst. Now, when I add catalyst, we said what happens to the reaction. The reaction becomes faster, and that means the graph would be steeper slope. So that would be the new graph. How does the speed of this reaction vary with time? Now, is the rate increasing with time or decreasing with time? We said if the graph looks like this, and then that means that it is very fast at the beginning, and then it's slowing down, and then at the end actually the rate is 0. So what happens to the speed? It decreases. Now, why does the speed of the reaction vary with time? Because the particles of the reactants are being used up, so less collisions. Okay, if you want to be specific, you can say, but here he's asking in general, You can say particles of the specific reactant that you have, C6H5N2Cl, are being used up, so less collisions. Here it doesn't make a difference because you have only one reactant. But if you have two reactants, you have to specify which one of them is being used up, and it is usually the one that is not in excess, the one that is limiting. Okay, reactions involving enzymes. The following graph shows how the speed of such a variation of a reaction varies with temperature. Suggests an explanation why initially the reaction speed increases, then above a certain temperature the speed decreases. We said, remember, that this is something that involves enzymes, so increase in temperature increases the rate at the beginning, just like any other reaction, since particles gain more kinetic energy, move faster, collide faster. But then at higher temperatures, because we're talking about enzymes, at higher temperatures the enzymes are denatured, so rate decreases. Remember that an enzyme has a specific shape that will fit whatever it's trying to work with. Now if you put it at a higher temperature, because this is made of a protein, it changes its shape. So we say enzymes are denatured, so they no longer act as catalysts, so the rate decreases. Okay, here he says a small piece of marble, calcium carbonate, was added to 5 centimeter cubed of hydrochloric acid, concentration this at 25 degrees centigrade. The time taken for the reaction to stop was measured. The experiment was repeated using what? Using different solutions of acids. The acid was in excess in all of the experiments. So they used a specific amount of calcium carbonate and they were changing the type of solution of acid. Okay, now explain why it is important that the pieces of marble are the same size and the same shape. Remember that if I'm comparing between the experiments, we said only one thing can be changed. Only one variable can be in the experiment. Everything else has to be the same. So here what are we changing? We're changing the type of solutions of the acid. But everything else has to be the same. So the mass of the marble chips should be the same. The size of the chips, the shape, the amount of marble chips, all of that has to be the same. So here he's saying, why is it important that the pieces of marble are the same size and the same shape? Of course, they have to be the same size and the same shape. I can't use once big lumps and in the other experiment smaller lumps. This needs to have same surface area for fair comparison, in order to compare between the results. How would you know when the reaction had stopped? What reaction is this? This is carbonate with acid, and we know that carbonate with acid gives what? It gives out a gas, bubbles of gas. So once the bubbles of gas have stopped, no more bubbles of gas, then that means that my reaction has finished. Okay, this is the table again. This is exactly the same table from the experiment. So explain why the reaction in experiment 1 is faster than the reaction in experiment 2. Okay, let's see what is the difference between experiment 1 and experiment 2. They were both at the same temperature, but the difference is experiment 1 is using hydrochloric acid with concentration of 1 mole per decimeter cubed, while experiment 2 is using hydrochloric acid with concentration 0.5 mole per decimeter cubed. So which one has a higher concentration? Experiment 1, and we said something that has higher concentration would be faster, and that is why it is taking less time. So experiment 1 has higher concentration of acid, so more particles, remember he's saying explain, more particles collide at the same time. If they have higher concentration, the rate is faster. Why? Because more particles collide at the same time. Okay, the other question says the acids used for experiment 1 and 3 have the same concentration. So in 1 I use hydrochloric acid 1 mole per decimeter cubed, but in experiment 3 I use ethanoic acid. They are both the same concentration, but why is experiment 3 slower? What is the difference between hydrochloric acid and ethanoic acid? You should remember that ethanoic acid is a weaker acid than HCl. So less H plus ions. And if I have less H plus ions, remember what was a weak acid? An acid that ionizes partially. So only some of the ethanoic acid will break up to form H plus ions. So I will have less H plus ions in the solution, so less collisions. Okay? One of the factors which determine the reaction rate of solids is particle size. A mixture of finely powdered aluminium and air may explode when ignited. An explosion is a very fast exothermic reaction. This causes a large and sudden increase in temperature. Explain each of the following in terms of collisions between reacting particles. Why is the reaction between finely powdered aluminium and air very fast? Of course, finely powdered means larger surface area, so more particles collide at the same time. Now explain why for most reactions the rate of reaction decreases with time. Well, the rate of the reaction decreases with time because whatever it is we're working with, the particles are being used up, so less collisions. Remember how to explain each factor. Suggest an explanation why the rate of reaction in an explosion could increase rather than decrease. Now, he says somewhere that the explosion is a very fast exothermic reaction. And you see at the beginning of the experiment, an explosion is a very fast exothermic reaction. So he's saying, suggest an explanation why the rate of reaction in an explosion could increase rather than decrease. We're saying in all reactions, at the beginning the rate is very fast and then decreases. But what if I have an explosion? Well, an explosion, we said explosions are exothermic. Exothermic means it gives out heat, and that means that the temperature of the reactants rises, so particles have more kinetic energy, move faster, collide fast. So it's as if I am heating the reaction because the reaction itself is producing heat. Okay, give another example of a substance other than a metal which, when finely powdered, might explode when ignited in air. Now, I didn't mention that in the explanation, but it is in the notes. Flour mills. There are flour mills are factories that make flour. Do you understand the meaning of flour? Flour, F-L-O-U-R, is what we use to make cake and bread and things like that. So, finely powdered flour, sometimes the flour mills have explosions because when the flour is ground, when it is ground to form very small pieces or powder, this means we have more surface area exposed to the air, and that means flour, remember, are carbohydrates. Flour is carbohydrates, so it will react, it will burn in oxygen to form carbon dioxide and water. So that is a very fast reaction if the flour is in the form of fine powder. Okay, describe a simple test tube reaction which shows the effect of particle size on the rate at which a solid reacts. Now, when he says something like this, he could say the effect of anything on the rate. But in this case, because we are talking about effect of particle size, okay, then what do we say? We put equal volumes of dilute HCl into 2 test tubes and then add 2 grams of the powdered calcium carbonate to the first test tube and 2 grams of large pieces of calcium carbonate to the other. The one that gives more bubbles is faster. Of course, we just chose calcium carbonate because it's a solid. He's saying show the effect of particle size on the rate at which a solid reacts with a solution. So we chose carbonate and acid, put equal volumes of the acid and then equal amounts of the carbonate, but the only difference is in one you put the 2 grams powdered and in the other one you put the 2 grams large pieces. The one that gives more bubbles is the faster reaction. Okay, the reduction of silver bromide to silver is the basis of film photography. An opaque object is placed on a piece of paper coated with silver bromide, which is then exposed to a bright light. The light is switched off and the opaque object removed. Remember that what happens is we have on the film, we have silver ions, and we said the silver ions are white. It gives the paper a white color. Now, any part of this that is exposed to light will gain electrons and become silver, so it becomes black. A part that is not exposed to light will remain white because it remains silver ions. So explain how the image is formed. We said the part exposed to light becomes black since Ag plus ions gain electrons and become Ag metal, which is black. The part covered with the opaque thick cardboard remains Ag plus ions, and that means it remains white. Explain the term photochemical reaction. Now I'm going to tell you again that photochemical reaction is a reaction that requires the presence of light to make it faster. Any reaction that needs light to make it faster is called photochemical reaction. Give an example of a photochemical reaction and explain why it's important. We had given the example of conversion of Ag plus to Ag in black and white photography, or you could say the use of light in photosynthesis of plants. Okay, 2 experiments using catalysts were carried out. Catalysts R and S were used to break down 50 centimeter cubed of aqueous hydrogen peroxide. Remember, the hydrogen peroxide is a solution that we always use in many experiments. It breaks down to form oxygen. If we add a good catalyst, that reaction is much faster. Okay, the volume of oxygen given out was measured using the gas syringe. The gas syringe diagrams show the volume of oxygen formed every 30 seconds in each experiment. Use the syringe diagrams to complete the volumes in the table. So you have these, and I hope you were able to read the syringes properly. So that first one, at time 0, both of them have a volume of 0. At time 30, the first one is 23 and 16, then 34 and 36, and so on. Please compare your numbers. They should be exactly the same. Okay? One wrong number, you lose 1 mark. So for each wrong number, you lose a mark. Okay, and then we're supposed to plot a graph. Okay, let us revise how to plot a graph. First of all, you need to label the axis. Now let's go back to the table. What will be on the x-axis and what will be on the y-axis? Remember that anything on the left of the table, so the time in seconds, that goes down on the x-axis. And whatever is on the right of the table, so here we're going to say catalyst, or volume per centimeter cubed for each catalyst. So that is what we're going to plot. And then if you have 2 graphs on the same paper, then you need to use one notation for the first one and the other notation for the second one. Notations that we always use are a small x, or a dot with a circle, or an x with a circle. So let us see how this graph should look like. So the first thing you do is you label the axis. Time in seconds, you label it time and the unit. Time in seconds, volume in centimeter cubed. And then you divide it so that you use as much of the graph paper as possible. So again, I'm going to go back. What are the numbers that we're plotting? Now the time in seconds go from 0 to 180. So I need to divide it so that the maximum is 180. The volumes, the biggest volume I have is 72. So I have to do it so that the volumes are correct. So 10, 20, 30, 40 up in the volumes will reach up to 70. And then we plot. And we said when we plot a graph, you plot it with small x's. Actually, the x's should be smaller than what I wrote, but I just made it a bit bigger to show so that they can be shown. And either x's or dots with a small circle. You never plot a graph using only dots, because once you join the graph, your points should be clear. The examiner will follow your points, and any point that is wrongly plotted, you lose a mark. Okay? So plot the points with small x's, and then when we join, we call it a curve of best fit. So if I have a point that is way off from the curve, I do not include it. I don't go in and out again. It should be a smooth curve. One point is away from the curve, I ignore it, and I try to take the best fit curve between all the points. Okay, so once I have done one of them, then this graph is all x's, and I label that this is graph R, and then I plot the other graph. So here it's a dot with a small circle, and I label that S. So this is my graph as it should look. Okay, now which result using catalyst R was inaccurate? Of course, the one that is inaccurate was the one away from the curve, so that was actually at 60 seconds. Which is the better catalyst, R or S? Remember, we said the better catalyst is the one that will make the reaction faster, and the one that has a faster reaction is the one in which the graph is steeper. So R. Now why is that? Because there is more gas collected in less time. When the graph is steeper, let's say in 1 minute, the amount of gas collected in 1 minute in R is much more than in S. So more gas is collected in less time. Now sketch a line on the grid, and that means on the graph that he has, that you've already drawn. So this is the grid that you have already drawn. Now you're going to sketch something else. You're going to sketch a line to show the graph you would expect if the reaction with catalyst R was repeated at 50. If we go back, you will find that the original experiment was made at 20 degrees centigrade. Now he wants it to be at 50. Now you're going to ask yourself, changing from 20 to 50, is the experiment going to be faster or slower? Faster. Faster means that the graph will be steeper. So you want to draw a graph that is steeper, that means going up faster, but since we are not changing the amounts, then it will have to end at the same volume that the other experiments ended. So this is what the graph should look like. Okay, the next experiment says the decomposition of hydrogen peroxide is catalyzed by manganese oxide. And he gives you the equation. To 50 centimeter cubed of aqueous hydrogen peroxide, he put 0.5 grams of manganese oxide. The volume of oxygen formed was measured every 20 seconds, and he measured the rate. Explain how the average reaction rate was calculated for the first 20 seconds. Now, if you think about what do we mean by rate, rate is a certain volume per time. So we want a certain volume over the time. So from 0, when at the time from 0 to 20, what was the volume collected? The volume collected was 48. So 48 in 20 seconds. So it's 48 over 20 seconds, and that is why he got it to be 2.4. And that means for the next 20 seconds, that means from 20 to 40. Now from 20 to 40, that is 20 seconds. Now how much gas was collected within that 20 seconds? He started with 48 and he ended with 70. So the difference between them is the amount of gas collected, and that is the volume. So divided by 20, it comes out to 0.1. Now he wants you to complete the table. Now the rate that you're going to draw in these dotted lines is the rate for the time between 40 seconds and 60 seconds. So between 40 seconds and 60 seconds, this is 20 seconds. Now how much gas was collected in that period? It's from 70 to 82. So actually they collected 12 centimeter cubed in the 20 seconds. So 12 over 20, that comes out to be 0.6. So that is what you put in the graph. Okay. Explain why the average rate. So as you see, the rate is decreasing. The average reaction rate is changing from 2.4 in the first 20 seconds to 1.1 to 0.6 to 0.3 to 0 in the end. So why is the rate decreasing? Again, we're saying the reactants are being used up, so less collisions. Okay. The experiment was repeated, but 1 gram of manganese oxide. Remember that the reactant here is just hydrogen peroxide, right? Okay, the experiment was repeated, but 1 gram of manganese oxide was added. What effect, if any, would this have on the reaction rate and on the final volume of oxygen? Okay, so you added a catalyst to this reaction. What is the effect on the rate? Of course, if we add a catalyst, the rate becomes faster, or the rate increases. Why? Because catalyst lowers the activation energy, so more effective collisions. But if I add the manganese oxide, what effect on the final volume of oxygen? The final volume of oxygen is not determined by presence or absence of the catalyst. It is determined by the amount of reactants that I'm using. So actually, whether I add a catalyst or not, there is no effect on the final volume. It just affects the rate, not the final volume, because the volume of H2O2 I'm using is the same in all the experiments. Okay, this is the other type of experiment where he puts hydrochloric acid with sodium thiosulfate, and this forms a precipitate. So to measure the rate, he puts the flask on a printed sheet. A student used this method to investigate the effect of changing the concentration. So in this case, we're using different concentrations of sodium thiosulfate, and we're trying to determine the effect of that on the speed of the reaction. The student used different concentrations of sodium thiosulfate solution. All other variables were kept the same. So give two variables which were kept the same in this experiment. What should I keep the same in both experiments? Well, we should use, for example, the same concentration of HCl. We should keep it at the same temperature. So remember that when you change one factor, you keep all the other factors the same. Okay, the results of the experiment are shown plotted on the grid. Now draw a line of best fit. Remember, if he says a line of best fit, that means a straight line going through most of the points. If one of the points is way off, you do not include it. Okay, so just two reasons why not all of the points lie on the line of best fit. So why isn't all the points on the same? This may be due to anything. Maybe the temperature increase, for example, or he made an error in timing. Remember, the error in timing is the one where we say, okay, has the printed sheet disappeared, or has the reaction finished or not, or should we stop, or should we not stop the clock, and so on, because it is very difficult to determine exactly when all the printed sheet has disappeared. Okay, from your graph, deduce the speed of reaction when the concentration of sodium thiosulfate is 0.075. So you look at the graph and you try to determine where is 0.075. Notice that the x-axis has from 0.0 to 0.1, 0.2, 0.3. So 0.075 is actually somewhere between 0.05 and 0.1. And then we go up to the graph, go left, and see where the speed of the reaction is, and that comes out to be 0.064 units. Were you able to get 0.064? Because it is somewhere between 0.04 and 0.08. So between 0.04 and 0.08, I have in the middle exactly is 0.06. So this is not exactly 0.06, this is a little bit higher, so that is 0.064. Explain why the speed of reaction increases when concentration increases. Again, concentration increases, that means more particles, so more collisions occur at the same time. Always you have to mention the word collision in your explanations. You cannot explain anything regarding rate without talking about collisions. Sketch on the grid the line you would expect if the experiments were repeated at a higher temperature. So you have this, the first one is the one you drew. Now you need to draw another line in the same exact way, but if it is done at a higher temperature, then that means that it is a faster reaction, and so the new line will be a steeper slope, or will have a steeper slope. Okay, this experiment has dilute sulfuric acid with zinc carbonate. So this is acid with carbonate that gives out carbon dioxide gas. Two experiments were carried out. The flask was placed on a balance and the mass of the flask and contents recorded every 5 minutes. The temperature of sulfuric acid was 30. The results have been plotted on the grid. Now experiment 1 was repeated, but the temperature was different. So he gives you one of the experiments and he tells you to plot the other experiment. So let's plot the other experiment. So if he used x's in his first experiment, then we're going to use dot with a small circle in ours, and then we join with a line of best fit, and this is experiment 2. Okay, were you able to get something like that? Okay, now he's saying, why does the mass of the flask and contents decrease? Again, I go back and see which reaction are we talking about. Well, we're talking about carbonate and acid. That means carbon dioxide gas is given off, and that is why the mass decreases. Why are we putting a cotton wool? So just the purpose of the cotton wool. We said the cotton wool is there to do what? To prevent loss of solution by splashing. In which experiment was the loss of mass of the flask and contents the fastest? Now, looking at the two lines, which one was fastest? The experiment 1 was fastest. The one that he had already drawn was faster because it came down more quickly. Compare the temperature of the sulfuric acid. Now, if experiment 1 is faster, that means it was at a higher temperature than 2 or at a lower temperature than 2. If we have 1 is faster, that means it is at a higher temperature. So experiment 2 must have been at a lower temperature. Okay? Now, use the graph for experiment 1 to find the time taken for the mass of the flask and contents to decrease to 120 degrees centigrade. So this is the graph again that we just drew. Indicate clearly on the grid how you obtain your answer. So he wants the mass, he wants the time taken for the mass of the flask to decrease to 120. Where is 120? We're talking about experiment 1. The graph for experiment 1 is not reaching 120, so I have to extend the line to 120. That is what he means by indicate clearly on the grid. And then I read off the time. If I read the time from there, the time is 18.5 minutes. Were you able to get that? Okay, on the grid, sketch the graph you would expect if experiment 1 was repeated using more concentrated sulfuric acid. So 1 has a certain concentration. Now if I repeat it with more concentrated, that means faster, it will go down much faster. Okay, so this is the one with the higher concentration. Okay, thank you for listening to this. That's the end of this questions, and we'll meet again in the next video. Okay.